Hello guys, good morning to all of you. In today's lecture, we are going to study conservation of momentum and equilibrium of a particle. This is part of chapter number 5, Laws of Motion, Physics, CBSE, NCERT for class 11th. So before I start, I would like to request one and all to subscribe to our YouTube channel and click on the bell icon to receive the future notifications. I also exhort you to please share our YouTube channel so that maximum people can make use out of it. So we will start with conservation of momentum. So what do we mean by conservation of momentum? So conservation of momentum means, suppose we are not doing anything to a system, so total momentum of the system will remain conserved. In other words, suppose a system is isolated. For an isolated system, the total momentum will be conserved. Total momentum is conserved. This is principle of conservation of momentum. So better to discuss the principle of conservation of momentum with the help of examples, some examples. So for example 1, in a spinning top, so how the momentum is conserved in a case of spinning top? So what happens when top spins? So we will take any point on the top, so it will be moving in one direction, and there will be a point opposite, there will be a point opposite to the first point taken, and it will be spinning in the opposite direction. So what does it mean? So for any point on the spinning top, there will be another point. Why there will be another point? The top will be, spherical or circular in shape. So one particle, one point on the top is moving in one direction, and the opposite point on the top will move in other direction. Okay, so as in total what will happen? Momentum gained in one point will be cancelled by momentum lost in other point. Okay, as we know that momentum is mass times velocity. So velocity is different, it is having different directions on different point. So in total, before we started spinning the top, the momentum was 0. So when it is spinning, it again will be 0 in total. Okay, so that is case of a spinning top. Now example 2 we will take. Example 2 is bullet fired from a rifle. So whenever we are going to fire a bullet from a rifle, the gun is going to recoil. Okay, suppose bullet is going in the forward direction and the gun will recoil in opposite direction. Okay, that is called as recoil of the gun. Okay, so there will be momentum of the bullet in forward direction. Normally we are going to fire the rifle in forward direction, bullet will go in forward direction, and recoil will be in the backward direction. Okay, so what will happen? So the rifle is recoiling in the backward direction and bullet is going in the forward direction. Okay, so we are taking it in this manner. The momentum of the bullet will be mass of the bullet into velocity of bullet. Okay, and momentum of the gun or rifle will be mass of the gun into recoil velocity of the gun. It will be equal and opposite. It will be equal and opposite. So in this case also total momentum will be conserved. Third example is of rocket propulsion. So whenever we are going to propel a rocket, so rocket, what will happen? There will be burning of the fuel. Okay, so we know that momentum is mass times the velocity. So whenever there is burning in the fuel, so first thing comes into our mind is this mass is decreasing, so momentum will also decrease. But no, in this case momentum will not decrease. Whenever there will be burning of the fuel, so according to the mass energy principle, the fuel burnt will be converted into energy, and that increased energy will be translated into the motion of the rocket. Okay, so earlier there will be some momentum, and after some time when the burning of the fuel had taken place, there will be loss in the mass and gain in the velocity. So in total the momentum will be conserved. Okay, that means mass into velocity will be conserved in case of rocket propulsion. Okay, so mass will decrease and velocity of the rocket will increase. So total momentum will remain conserved. That is example number 3. So now we will move to collision of bodies. So collision we are going to discuss in depth in chapter work, power and energy, but briefly we will touch collision. Collision is the interaction between two particles. Okay, they may touch each other or they may not touch each other, but there will be interaction. There will be interaction between two particles or two bodies, we can say. Okay, suppose we are having two bodies. Suppose we are having two bodies, body 1 and body 2. Okay, so initially they are having momentum P1 and P2. That means body 1 is having momentum P1 and body 2 is having momentum P2. Okay, after that they are colliding. So whenever they will collide, there will be change in their momentum. So what will happen? Their new momentum will become P1 dash and P2 dash. That means before collision, the momentum of body 1 was P1 and momentum of body 2 was P2. But now they are colliding. Now they are colliding. So their momentum has become P1 dash and P2 dash. Okay. So now, although we don't need to study law of motion, second law of motion here, we will briefly borrow the formula and we know that F is equal to dP by dt. This is second law of motion. Okay, in the mathematical form. So F is equal to dP by dt. So we are talking about F12. F12 means force on body 1 due to body 2. So it will be change in the momentum. The momentum of the body 1 after collision is P1 dash and momentum of the body 1 before collision was P1. So we can write F12 is equal to P1 dash minus P1 by delta t and F21 is equal to P2 dash minus P2 by delta t. And we know that from the third law of motion, by Newton. Okay, so what will happen? We will write F12 is equal to F minus F21, equal and opposite. Okay, the forces, action, reaction pairs will be there and they will be equal and opposite. So put these formulas, you will get P1 dash minus P1 by delta t is equal to P2 dash minus P2 by delta t. They are interacting for a brief interval, that is delta t. Okay, so by simplifying we will get P1 dash minus P1 is equal to P2 dash minus P2. So further simplifying and rearranging the term, we are getting P1 dash plus P2 dash is equal to P1 plus P2. That means the momentum after collision is equal to momentum before collision. In other words, momentum is conserved. Okay, so I hope you got it. So total momentum of an isolated system is conserved. That means suppose two bodies are colliding with each other. So their momentum before collision will be equal to their combined momentum after collision. This is a special case of collision of bodies. So whenever we are going to study collision in our next chapter, this will be pretty much of help. We need to understand and memorize this collision of bodies. So now we are talking about equilibrium of a particle. So when a particle is said to be in equilibrium? A particle is said to be in equilibrium if net external force on it is 0. Okay, so a particle is said to be in equilibrium if net external force on it is 0. There are two types of equilibrium. One is static equilibrium, another one is dynamic equilibrium. In static equilibrium, the particle will be at rest and it will remain in rest. That is static equilibrium. And in dynamic equilibrium, the particle will keep on moving with the same velocity, constant velocity. So why this will happen? This will happen due to the reason that there is no external force. When there will be no external force, static equilibrium and dynamic equilibrium will be achieved. The body at rest will remain in rest and body in motion will remain in motion with constant velocity. Okay, and unless and until an external force is acting on it. So how will we describe equilibrium mathematically? Okay, so whenever we are talking about a particle in equilibrium, so mathematically it means that sum of all forces acting on the body is 0. Okay, that means balance or resultant force will be 0. Okay, suppose this is a point object and number of forces is acting and the body is in equilibrium. Equilibrium may be static equilibrium or dynamic equilibrium. So if it is in either of the two equilibrium, what will happen? The total force acting on the body will be 0. Total force acting on the body will be 0. That means sigma F is equal to 0. Okay, also we know that we studied in a motion in a plane under vector heading that a force can be resolved in components. Okay, so whenever we are talking about a particle in 3 dimension, that means there are 3 Cartesian component will be there. So individually we will tell fx, sigma fx will be 0, sigma fy will be equal to 0 and sigma fz equal to 0. That means if a particle or system of particle is in equilibrium, then the component of force along x-axis will be equal to 0, means the summation of the component of the forces along x-axis will be equal to 0. Summation of the forces, component of the forces along y-axis will be 0, and summation of the component of the forces along z-axis will also be 0. So sigma fx equal to 0, sigma fy is equal to 0 and sigma fz is equal to 0. We are going to use this concept in numerical problems in this chapter. Okay, so we will do one numerical problem in fact on this concept. So this is numerical problem. So I will read out the problem for you. So problem goes like this: a mass of 6 kg is suspended by a rope of length 2 meter from the ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint P of the rope as shown. Okay, so it is asking what is the angle the rope makes with the vertical in equilibrium. So what data is given? First data is mass of 6 kg. This is mass of 6 kg. Okay, is suspended by a rope of length 2 meter. We are given rope of length 2 meter. Okay, so after that a force of 50 Newton is applied at the midpoint P of the rope. This is the midpoint and here we are applying force of 50 Newton. Okay, so now what is asked? They are asking what is the angle rope makes with the vertical in the equilibrium. It is given that system is in equilibrium and it is asking for this angle theta. It is given in the figure. This angle theta they are asking. So what will happen? We are knowing that there will be a force known as tension in the rope. There will be tension in the rope. So T1 we are considering tension in the rope. This T1 is the tension in the rope. So we are resolving T1 into 2 components. Okay, now we know that there is an angle the rope is making with the vertical in the equilibrium. Okay, so T1 will be resolved into 2 components. One vertical component and one horizontal component. Horizontal component will be equal to T1 cos theta and vertical component will be equal to T1 sin theta. Okay, so now we will apply principle of equilibrium. So fx has to be 0 and fy will be equal to 0. Now we know that it is T1 sin theta will be equal to 50 Newton. It is given that we are applying force 50 Newton as given in the diagram. Okay, so we are taking at point P. We are considering point P. We are knowing that point P is in equilibrium. So horizontal component will be equal to 0 and vertical component will also be equal to 0. So that means T1 sin theta will be equal to 50. Okay, and now there is another component T1 cos theta. T1 cos theta will be equal to mg. Okay, we know that 6 kg weight is given, a body weight is given. So you know that weight of the body will be equal to mg. M is given as 6 kg and g is 10. We are taking on earth. On the earth, value of acceleration due to gravity is 10 meter per second square. After truncating the decimal point or rounding off, we are rounding off it and we are getting 10 as the value of g. So weight of the body will come to be 6 into 10, 60. And T1 sin theta will be equal to 50 and T1 cos theta will be equal to 60. So now simplify it. How will you simplify? You will divide first by second. T1 will get cancelled. You will get tan theta is equal to 5 by 6. So now theta will be equal to tan inverse 5 by 6. And by making use of the trigonometric table, So when value of tan theta is 5/6, the value of theta has to be 39.8. So after rounding off, it is coming to 40. So this is one example we have discussed, okay, on the basis of concept of equilibrium. Okay, so we have to resolve the forces, okay, and then we need to take delta fx is equal to 0, we need to take sigma fx is equal to 0 and sigma fy is equal to 0, and then we have to solve and get our required answer. That's how it will work. Okay, so thank you very much for your patient listening. Thank you. See you soon in our next video. Thank you.